The first line tells that the Windows.h provides access to the window API for memory mapping, process creation, and synchronization crucial for the shared memory and process handling in Windows. The Studio.h stands for a IO library used for printing error message and debugging information. Next one is student library.h. This is including function for dynamic memory allocation, malloc, free, process control, and random number generation. String.h function for memory and string operation like copying and setting. The limits.h defines constants like int max used for a initial maximum value in the merging logic. Array size Array size is defined as specific the total size of the array 10 million integers to be divided among children process. Num children is equals to number of children process. Adjusting this value changes the degree of a parallelism. The next one is child array size. Computes the size of the segments each child will handle divide by dividing the array size by the number of a children. The next is int I, a global variable used for a loop counter throughout the program, and declaring the two function used later. Generate random array fills the array with the random integer between 0 and 999. Merging sort array merges sorted segment produced by the children process into a single sorted array. Next is the main function. Memory allocation. Memory allocation for a main array line number 17 to 22. The dynamic allocates memory for main array to store 10 million integers. Check if malloc return now null, including a fail due to a insufficient memory. Exit with an error message if memory allocation fails. The number 2 is generating random array, line number 21. Generating random array, main array size populates main array and random integers using a generate random array functions. And next one is creating shared memory, line number 26 to 34. Handling the hmap file is equals to create file mapping in invalid. Creating a file mapping creates a shared memory object in the system's virtual memory. The next one is invalid handle values includes the shared memory is not right to be physical file page read write, allowing both the read and write access to a shared memory. The next one is array size. Size of int allocates memory equivalent to a size of an array. The next one is text. Local and shared memory is a name of the shared memory region for access by parent and child process. Next is check if the handle hmap file is null and exit if creation fails. Next part will continued by
In line number 36 to 42, map the shared memory object into the parent processor's address space. Allows the direct access to the shared memory through the pointer shared array. Checks if mapping fails and exits with the cleanup. Next, in line number 44, it copies the randomly generated array main array into the shared array shared memory. In line number 46 to 65, it it iteratively spams num children processes and create process executes the children.exe, passing the start index and size of array segment as arguments. Each child process sorts a distinct segment of the array. In line number 67 to 73, wait for all the child processes to finish sorting their respective segments, closes process and thread handles to release resources. In the line number 75, calls the merge sort arrays to merge sorted segments into a single sorted array. In line number 77 to 80, it cleans up the memory and resource allocated with the shared memory and the main array. In line number 82, it finally prints a successful message after sorting and merging. Next, In function generating random array, which in line number 87 process declares the function to populate an integer array with random values parameters into int star array, a pointer to the array to populate, and int size, the size of the array. And line number 88 start a for loop that iterates size time to populate each index of the array. The next is the global variable I declares is used to the loop counter. In line number 89, the modules operator ensures the random number line lies in the range of 0 to 9999. The random value is stored in the I index of the array. In line number 90, closes the for loop. After this, every element of the array is populated with random integers. In line number 91, closes the function. At this point, the array is fully populated.
Start. Line number 93. Int array pointer to array containing a storage segment. Int size total number of elements in array. Int num segment number of stored segment to merge. Int segment size number of element in each segment. Line number 94 to 95. Dynamically allocated to temporary array temp array to hold the merged result. Checks if memory allocated fails. Null. Print an error message in line number 96 and return. Line number 100 to 105. Allocated an array indicates to track the current index in each stored segment. Installing all the indicates to 0 using checks if allocated fails and freeze temp array before returning. Line number 107. Installing result index to track the position in temp array for storing the index next smallest value. Line number 109 to 127. Line number 110 to 111. Main value tracks the smallest value in the current iteration. Main index tracks the segment the smallest value comes from installing to -1. Line number 112 to 119. Checks if there are elements left in the current segment. If a current value is smaller than main value and updates main value and main index. Line number 120 to 127. If valid smallest value is found when index equals to -1 stored in the temp array and it updates indicates if no valid segment is found, all segments are extracted. Exit the loop. Next part 4.
In line number 135, uh, the memory copy the memory copy function will copies the content of the stored temp array back into the original array. In the 136 and 137 line number, free temp array and free indices, it will freely dynamically allocated memory for temp array and indices to avoid memory leaks. Uh, in line number 138, the program will end. At this point, the array contains the fully merged and sorted values. Now we come to the summary of the parent program. The parent program orchestrates the sorting of a large array by splitting the task across multiple child processes and merging the results. Here is the step-by-step summary of parent program. Setup and initialization. It allocates memory for a large array with minimum of 10 million integers. It fills the array with random numbers using generate random array function. Shared memory creation. It creates a shared memory object like create file mapping accessible to both parent and child processes. It maps the shared memory to the parent's address space. It copies the content of main array into the shared memory for child process to access. Child process creation spans num children child processes create process. Each assigned a portion of the array to sort. It passes the starting index and size of the assigned segment to each child via command line arguments. It waits for all child processes to complete their task using wait for signal object. It ensures that it ensures that all segments are sorted before proceeding to the next step. Uh, it invokes the merge sorted array function to combine the sorted segments from the shared memory into a single fully sorted array. It unmaps and closes the shared memory handle. It frees the dynamically allocated memory for the original array. Uh, Completion of the program outputs a success message after the merging is finished. The key features of the parent program are uh, parallelism, shared memory, scalability, and robustness. Parallelism uses the multiple child processors to sort different segments of the array concurrently, leveling multi-core processors for efficiency. Uh, Shared memory facilitates communication between the parent and child processors without duplicating data, optimizing memory usage. Scalability. Number of child processors can be adjusted based on the system capabilities. Robustness includes error handling for memory allocation, process creation, and shared memory operations, ensuring the program exists gracefully in case of failures. The parent program ends here.
Next, we start the part 5. It is child program, childhood explanation. In the header files, there is a hash include Windows and hash include studio.h and hash include statelab.h. In hash include Windows, it provides access to Windows API functions which are used to interact with the operating system for shared memory management. In hash include stdio.h, it provides some functions for input and output operations such as fprintf to print error messages and information to the console. Next, hash include statelab, it includes functions like auto to convert strings to integers and memory management functions. Next, we go to function prototypes. In void sort array, int array int size, int compare, it constant void a, constant void b, sort array. This function will sort a portion of array using the qsort function. Compare, a function used to qsort to compare two elements in the array for sorting purposes. It returns a value indicating the relative orders. Now let's enter to the main program. Step 1, valid command lines argument. For fprintf, stdr usage or start index, and we give the size, then return 1. The program accepts two arguments passed through the command line. Start index, the index where the segment of the array starts, says the number of elements in the segment to be sorted. Next, the step 2, pairs command line arguments, int start index, then int array size. ATOI converts the start index from the command line to an integer. ATOI2 converts the size of segment from the command line to an integer. Step 3. Open shared memory. Handle HMAP file. Open file mapping. The file will be opened in the local shared memory disk. If HMAP file is equal to null, then print could not open the file for mapping object. Then get lost error. Return 1. Open file mapping. These functions open an existing file mapping object created by the parent process. It allows the child process to access the shared memory region where the array is stored. File map all exists. Specifies that the child process both read and write access to shared memory. False. Indicates that the file mapping is not inheritable. Text in local shared memory. The name of the shared memory object. This name must match the name used by the parent when creating the shared memory. If HMF file is equal to null, then it prints specific error code from get lost error and returns one to terminate the program. Thank you, friends. Next, our friend Venkatesh Desai will continue.
Thank you, Anjan. Here I am going to explain about line number 25 to 30 and myself, Venkatesh. Map shared memory in line number 25 to 30 in shared array int map view of a file is accessible to 000 if shared array equal to null. Fprintf equal to cloud not map view of a file percentage d close the handle and file map return 1 and map view of a file maps the shared memory object into the child process address space parameters. File map all access grants read write access. The zero value specifies the mapping starts from the beginning of the file. The size is determined to automatically error handling. If mapping fails, prints an error and closes a shared memory handle before exiting. Sort assigned segment, sort array and shared array, start index, array size. Also sort array to sort the assigned portion of the array and shared array pointer to the starting index. The segment is shared memory array size number. In line number 34 and 35, unmap view of a file shared array. Close handles the map view of a file. Unmap view of a file unmaps the shared memory from the child process address space. Releasing the map is close handle closes the handle to shared memory object. And in line number 37, a return 0 exits the program with a success status and sorting the array function. Function definition in line number 39 to 40. Uh, Wide sort array int array each size and size of the array is compared purpose. uh, Sorts an array segment using the standard C library q sort function parameters int array pointer to the segment of the array to sort int size number of elements in a segment q sort parameters and array is the sort uh, array is used to sort the size the number of elements in the array and the size of the each element in the bytes typically 4 bytes and compared uh, pointer to the cooperated function compare function unaction defines line number in 42 to 46 it compared uh, Karthi next line please next line code ಇಲ್ಲೇ ನೆಕ್ಸ್ಟ್ 42 46 ಐತಿ ನನ್ ಕಾಣಿಸ್ತಿಲ್ಲ ಇದು connection definition in line number 42 to 46. It compare consists wide and in int a int b equal to int into int b return int is greater than Hmm. ಅಷ್ಟು ಪೂರ ಐತಾ ಚಿಂಗಿ ಲೈನ್ unaction definition starts from a line number 42 to 46. Int contains int wide cost b int a equal to int b and int b equal to int into by d. Return is lesser than int b and int is greater than int b. And the purpose of comparing the function used to use sort determining the order of two elements parameters consists of wide a pointer to the first element and the pointer in b is the pointer b to the second element process. As a and b int defines the access integer values compares the integer returns and if a is lesser than b and a is greater than b and a equal to b and next, my friend Karthik will going to execute the code.
The code, first we compile the parent one. Here it compiles with 0 errors and next with child one. And this also complete with 0 errors. Now we will run the parent one. It takes a few seconds, but it executes successfully. Here is the output, and now we will run the child program. Here is the output of the child program, and we have child program and child program. Left one is the parent program which executes successfully, and the right one is the child program. And here we compile the both child and parent program, and it will successfully sort and give the outputs.